Kia ora koutou katoa. So I'm Yun Singh from the University of Auckland from the School of Computer Science, and I'm going to talk a little bit about one of the projects that we've been carrying on for a couple of years now in Continual Learning for Adaptive Predictive Systems. And I'm going to go into a little bit about what my group does. So we work on data streams as well, and as Albert pointed out, data streams is a sequence of observations that arrives at fast pace. Usually it's assumed to be infinite, and distribution may change over time. What this means is that your model that you built at any one point may no longer hold in the future. So predominantly we look at a couple of things when we look at continual learning for these data stream problems. One is, how do we actually deal with the problem of concept drift, whereby we want to build a model that's reactive to current drifts, which means that there's change, things are changing within your data streams, and capture these new learnings for your model. We also want to be able to proactively handle these. So if we can foresee that there is something that's going to change in the future, how do you deal with these? Beyond that, in today's short talk, I'm going to actually look at the cold start problem, whereby if we do not have enough information to start off your model, how do you do it if we have a data set that's from a similar domain that has statistical properties that are similar? So we want to be able to build a cost-effective strategies for model transfer. So in this particular project, Ocean Wu, which is one of our PhD students, supervised by myself and Jill that's here today, and she's actually currently at ICDM presenting this piece of work. So one of the things that we've thought about is, how do you cost-effectively transfer learning across data streams? So in this particular piece of work, what we're doing is we're trying to actually measure construction complexity in terms of, if we know a bit of what's going on within the new data stream, how complex is it to actually learn this new model? And can we actually infer properties of a different model to transfer across to it, such that we're actually utilizing and leveraging information from the other model in this new domain? So as a case study, what we did was we paired up with NIWA, National Institute of Weather and Atmospheric Research Center, specifically in their air pollution, air quality section. And within that, what they've done in the air quality scientists, they've actually gone out in a couple of towns within South Island, New Zealand, and they've put on little sensors that are low cost. And this is dotted across different towns. On the left, we see the little red dots of air quality sensors produced and put on in the town in Cromwell. And on the right, we have ones that are dotted across in Ricardo. What we wanted to know is, can we transfer information across these towns, specifically concentrating on forecasting air quality in those towns? We were predominantly interested in looking at wood smokes within those towns. So one thing that we want to actually point out, and intuitively what our model does, is it captures representations of air quality, or models air qualities across a specific town, and tries to actually adapt it across different towns. And we noticed that what our technique does is it tries to transfer when there is a reasonable amount of information that tells us that we're going to actually leverage good information. And then what it does is it also tells us that when we should not be transferring and actually building a model from scratch. So on the graphs that are in the middle, what we can see is that the red line is our model, what we're saying is, if we do transfer it, there are certain times we're actually able to adapt quicker. And on the right, we see that there are models that if you can't transfer it, and we do try to transfer it, and in the red dotted lines, you see that it actually deteriorates way faster. So as part of our mission to be open source, we actually produce open source package called Scikit-Ika. It's available and on the PyPy platform. So if anybody wants to try to use it, it is open. And as part of, in general, I'm just going to quickly go through what our lab does. Our lab predominantly focuses on working on projects that are for social good. So specifically, in our lab that's actually co-directed by myself and Joe Dobie, Professor Joe Dobie, we are currently supervising a range of students, and predominantly we're working in 3 different research areas: machine learning, environmental and climate, machine learning in health and medical domain, and machine learning for software and application itself. These are generally some of the projects that we're currently running, and that's us. Thank you.